Centuries before the modern era, one mind bridged the gap between myth and mathematics. This is Archimedes of Syracuse. The diagram before you illustrates his proudest achievement: the geometric relationship between a sphere and its circumscribed cylinder. He proved that the sphere's volume and surface area are exactly 2/3 that of the cylinder. But his genius wasn't limited to parchment. He engineered the claw of Archimedes to lift enemy ships from the sea and laid the foundations of hydrostatics. He didn't just study the world, he calculated its very mechanics. Syracuse has fallen. Amidst the chaos of Roman conquest, Archimedes remains unmoved, focused entirely on geometric figures traced in the dust. When a Roman soldier demands he surrender to General Marcellus, the mathematician utters his final, legendary plea: "Do not disturb my circles." To Archimedes, the eternal truths of geometry outweighed the immediate threat of the sword. In a moment of senseless violence, the soldier strikes him down. The light of Greek mathematics flickers, extinguished by the very empire that would later marvel at his mechanical legacy. To understand Archimedes, we must look to the map of the Mediterranean. Born in Syracuse, a wealthy jewel of Magna Graecia, he lived at the volatile intersection of rising Rome and fading Carthage. But his intellectual heart lay in Alexandria, the world's greatest center of learning. Through his correspondence with the geographer Eratosthenes, Archimedes remained connected to the pinnacle of Hellenistic thought. Funded by King Hero II, he became a rare hybrid of his era, a philosopher-engineer whose abstract brilliance was forged into practical and often deadly reality. The core of Archimedes' genius was his ability to bridge the gap between abstract geometry and the infinite. He pioneered the method of exhaustion, a precursor to modern calculus, allowing him to calculate the area of a circle and the volume of a sphere with startling precision. By treating physical shapes as mathematical entities, he was the first to prove that the laws of the universe could be written in the language of geometry. As historian E.J. Dijksterhuis noted, he established the vital interrelation between mathematics and mechanics, a leap that forever changed our world. How do you measure a curve without modern tools? Archimedes faced this problem and solved it with the method of exhaustion. He inscribed a triangle within a parabola, then filled the remaining gaps with progressively smaller triangles. By summing these infinite areas, he approached a precise limit, calculating that the area of the parabolic segment is exactly 4/3 that of the inscribed triangle. Using infinitesimals and infinite series, he laid the conceptual groundwork for integration, preceding Newton and Leibniz by 2 millennia. He didn't just solve a puzzle, he glimpsed the infinite. Of all his discoveries, this was the one Archimedes cherished most: the elegant symmetry between a sphere and its enclosing cylinder. He proved a fundamental mathematical truth: a sphere's volume and surface area are exactly 2/3 those of its circumscribed cylinder. To Archimedes, this wasn't just a calculation, it was a perfect harmony of the universe. He was so proud of this discovery that he requested this very diagram be carved onto his tombstone. Even in death, he wanted to be remembered by the beauty of the geometry he uncovered. Archimedes famously declared, "Give me a place to stand, and I will move the earth." While he didn't invent the lever, he was the first to unlock its mathematical soul. He provided the formal proof for the law of the lever: F1 times x1 equals F2 times x2. By demonstrating that magnitudes balance at distances reciprocally proportional to their weights, he turned a simple tool into a precise science. This mastery of equilibrium and center of gravity allowed him to envision machines that could multiply human strength to a godlike scale, forever changing engineering. A bathtub became the birthplace of hydrostatics. Tasked with proving if a crown was pure gold, Archimedes realized that his own body displaced water as he submerged. Legend says he ran through the streets shouting, "Eureka! I have found it!" By comparing the water displaced by the crown to equal weights of gold and silver, he exposed the jeweler's fraud. More importantly, he established Archimedes' principle: the buoyant force on an object equals the weight of the fluid it displaces. It's the reason heavy ships float, and a cornerstone of physics. Archimedes' brilliance wasn't just for war, it served the grandest ambitions of peace. King Hero II commissioned the Syracusa, a floating palace so massive it was the Titanic of the ancient world. To manage the inevitable bilgewater from such a colossal hull, Archimedes engineered the Archimedean screw. This rotating spiral efficiently lifted water against gravity, a design so perfect it remains in use globally today. From irrigation in the Nile Delta to the first screw-propelled steamships, his engine of peace proved that true genius elevates the world long after the battle's end. When Rome's 60-ship fleet descended upon Syracuse, they met the geometric Briareus. Archimedes transformed the city into a fortress of terrifying innovation. His improved catapults rained devastation at variable ranges with pinpoint accuracy. More legendary was the iron hand, or claw, a massive crane that plucked ships from the sea and dashed them against the rocks. While the heat ray of burning mirrors remains a subject of scientific debate, the Roman terror was real. Marcellus himself lamented that Archimedes used his geometry to bail out the sea and outfight an entire army single-handedly. Before we explore the machines of war and the laws of the sea, we must look at the mind behind them. Archimedes of Syracuse was the ultimate bridge between abstract thought and physical reality. He didn't just calculate, he anticipated the foundations of modern calculus by 2 millennia. This image captures his most cherished discovery, the perfect 2:3 ratio between a sphere and its circumscribed cylinder. It is a symbol of a man who looked at a chaotic world and saw an underlying, elegant blueprint. Archimedes' life ended in 212 BC, but his legend was only beginning. While Roman steel conquered his city, his ideas proved indestructible. He became the geometric Briareus, a figure of such immense intellectual power that later historians struggled to separate the man from the myth. From the legendary heat rays to the mechanical wonders that simulated the heavens, his work was reclaimed by history as the gold standard of human ingenuity. He remains the ultimate symbol of the scholar hero, a man whose mind was the most powerful weapon of all. For over a century after his death, the Romans largely neglected Archimedes' intellectual legacy, viewing mathematics as little more than a tool for practical measurement. His grave became a hidden ruin, swallowed by time and brambles outside the gates of Syracuse. In 75 BC, the Roman quaestor Cicero set out to find it. He discovered the forgotten monument not by a name, but by a geometric signature, the sphere and the cylinder he had requested in life. By clearing the brush, Cicero didn't just reclaim a tomb, he reclaimed a genius for the Roman world, proving that true thought can never stay buried. For centuries, some of Archimedes' most revolutionary ideas were lost, hidden beneath the prayers of a medieval monk. This is the Archimedes Palimpsest. In the 13th century, vellum was scarce, so Archimedes' original diagrams were scraped away to make room for religious text. It wasn't until the 20th century that multispectral imaging revealed the ghost writing underneath. This discovery gave us the only surviving copy of the method of mechanical theorems, proving that Archimedes was using physics to solve math long before the rest of the world caught up. Archimedes of Syracuse, the man who bridged 2 millennia. During the Renaissance, his rediscovered blueprints sparked a revolution. Galileo himself was awestruck, calling the ancient Greek superhuman, but the circle only truly closed recently. Using cutting-edge X-ray fluorescence, scientists peered through the erased parchment of the Archimedes Palimpsest. They found that the very foundations of modern physics and calculus were drafted over 2,000 years ago. Today we don't just study his work, we live in the world it built. The ancient past and our high-tech future are one. Step into the mind of Syracuse's greatest son. Archimedes wasn't just a mathematician, he was the ultimate problem solver whose influence radiates through 4 pillars of human progress. In mathematics, he laid the theoretical foundations for calculus, using his method of exhaustion to pin down the value of pi. He even counted the grains of sand in the universe to prove that numerical systems have no limit. His grasp of physics and hydrostatics gave us the eureka moment. By defining buoyancy, he didn't just solve the mystery of a king's gold crown, he gave every future shipbuilder the rules of the sea. But Archimedes was also a man of action. His inventions in engineering birthed the compound pulley and the famous screw that still lifts water for farmers today. When the Roman fleet threatened his home, his war machines, from massive catapults to the legendary claw, turned engineering into a terrifying defense. From the abstract beauty of a sphere's volume to the raw power of a leveraged beam, Archimedes didn't just observe the world, he mastered it. His legacy is the very map of modern engineering,